If you look at problem number 251, it mentions the threshold technique here. You can consider rejection as a synonymous term. It's also called rejection. The function of rejection is characterized by its ability to eliminate weak signals. This question asks what effect occurs when you increase the control here. So the correct answer is to choose option C. Therefore, you can see that the weak echo signals gradually disappear. With this, we've gone through the overall questions related to the equipment. Now, let's move on to the next part and continue solving the questions. The questions we've solved so far were related to ultrasound equipment. Starting from question 252, we'll solve a series of questions about how to apply the basic knowledge of this equipment in actual examinations. First, since question 252 covers important content, I'd like to emphasize it. The question asks which mode should be used to examine the gallbladder in real time. Various types of modes are described here. You definitely need to remember the characteristics of each one. The correct answer would be to choose option B. To examine the gallbladder, you need to look at its overall shape, so the examination can be performed using B mode. Next, let's move on and look at question 253. In the case of this question, it deals with the most important concept in this section. To explain it simply, this is about the relationship between frame rate, temporal resolution, or PRF. I want to emphasize that the relationships shown here are very important because they are always included in the exam. First, I'll briefly explain the basics and then we'll move on to solving the problem. First, let's review the concepts we already know before we get started. You only need to recall two main diagrams. The first diagram is a shallow sector shape like this. Just draw about 2 or 3 lines. For the second diagram, imagine a structure that is as deep as possible with many lines making up the image. You can see with the naked eye that the depth here is shallow. In this second diagram, the depth is configured to be deep. In the case of the first diagram, you can think of it as an image where the PRF or frame rate is measured to be high. In this case, you can think of it as the opposite. Now let's take a look at the most fundamental aspects that determine these things. You can think of frame rate as the efficiency with which a single image is produced. If the depth is shallow and there are fewer lines to process, you can create images that much faster. However, if the depth you need to reach is set this deep and there are multiple lines, the efficiency of creating images will also decrease accordingly. So, the greater the scanning depth becomes, and the higher the density of scan lines there are, and if the range itself is even significantly broader than what we see here, then the wider the sector angle becomes in this area, the more the overall frame rate will inevitably decrease as a result. When the frame rate drops here, the temporal resolution will also decrease at the same time. If you just remember the differences between these two diagrams, I can say that solving the problems will become much easier. Alright, based on this content, let's try solving some problems. Even if you don't know the previous material, you just need to choose the option that improves temporal resolution to answer the question correctly. If you look at each item in the options, when the number of focal zones or focused areas increases, the amount of work that needs to be done also increases, right? These factors can be considered as causes that decrease temporal resolution or frame rate. Similarly, as the depth increases, the value can also decrease. If the sector angle increases, the value will decrease as well. If you reduce the number of scan lines, the amount of work decreases and the number of images that need to be generated also decreases, so the frame rate can actually increase. The correct answer is to choose option D. Yes, this type of question will continue to appear in this section, so make sure you organize and understand these concepts well now. As you solve the problems, make sure to organize everything perfectly. Next, let's move on and look at question number 254. For this question, it would be good to remember the sentence together. The expression here is actually a sentence that explains frame rate. Expressions that ask how many images can be generated in real time or how many images can be produced per second are sentences related to frame rate. So if the frame rate is high, it means that a large number of images can be generated in real time. Conversely, if the frame rate here drops, it means that fewer images are being produced. Let me give you another example. Let's assume you're performing a cardiac ultrasound examination. In the case of the heart, since it is an organ that moves rapidly in real time, a large number of images are needed in real time. Therefore, you can see that a high frame rate setting is absolutely necessary. So try to remember these concepts together as a pair. Next, let's move on and look at question number 255. This question is not particularly important, so we'll skip it. Let's try solving question number 256. If you look at the question, it asks about which mode can be used to measure distance. You should know that distance can be measured in A mode, B mode, and M mode. So make sure to remember the characteristics of each mode. You can just remember that all three modes here can measure distance. Next, let's move on and look at question number 257. This question asks you to choose the statement related to the characteristics of the modes. Among the various modes, I want to emphasize that this mode is the one most frequently asked about on the exam. Let's briefly watch a related video. As you can see in the diagram, a single line is formed along the XR axis like this. So, you would position the line at the part where you want to observe the motion. You can think of the motion mode as appearing like this on the positioned line. A related keyword you can also use is TM mode. You can think of it as a mode where you can evaluate both time and movement together. Returning to the main point, if we look for the most relevant answer, we could choose D. The characteristic of this mode is that you position a single line of the reflector and observe changes over time. People often get confused and mistake it for C. It is true that it evaluates movement, but the part about applying multiple lines is incorrect. So I can explain that the expression single line is also important here. Next, let's move on and look at question number 258. This question is not particularly important, so I'll skip the explanation and move on. Let's look at question number 259. Yes, sometimes you'll see expressions about determining position when using pulse flow. The thing most closely related to determining position is always the term elapsed time. So, by sending out a sound wave and measuring the time it takes to return, you can determine the depth at which something is located. For terms related to this, you should select option B. The term echo ranging can be used here, or it's also called the range equation, which is the distance equation. You can consider that these expressions can be used together as well. The important point to remember from this question is that with pulses, you can measure the distance or depth of a reflector by using the time it takes for the pulse to go out and return. Just make sure to focus on this part. Since the next question is related, let's solve it right away. It has been measured that the time taken for the sound wave to go out and return is 26. Now that we have the time, we can measure the distance to some extent. According to the so-called 13 microsecond rule, if the travel time shown here is 13, you can set that as the reference value for a distance of 1 centimeter. If calculation questions like this are given, there's a high chance they'll be based on multiples of 13. Or, if it's 26, or if it's 3 centimeters, it could come out as 39. In the problem, it says that it took 26, so you can see that this is twice the value of 13. In the case of 26, you can think of it as a reflector located at a depth of about 2 centimeters. By reviewing these two problems, you can organize the concepts. And if calculation problems are given, they will be based on multiples of 13, so they're not particularly difficult. You can think of them as more like arithmetic than mathematics. Since calculation problems like these appear frequently, make sure to review them carefully.